There we go. Hello all. My name's Wilkinson, as I said there, and contrary to the fact that I do have quite an extensive range of certs, you're about to see in this presentation that they mean absolutely nothing. So bear with me here, folks. Just want to say big shout out to BSides Belfast. This is my first talk ever, and it's fantastic to be able to do that at the same place that I went to my very first conference. So happy days. Anyway, we're going to talk about detection as code. My background is incident response, so if anybody in here is in the blue team, worked in a SOC, incident response, this is going to be the talk for you today. So just a quick shout out to a couple of people in the industry who are absolutely fantastic. So if this talk tweaks your gears for getting into detection engineering, these guys are absolutely awesome. So Alex Teixeira is an absolute wizard when it comes to detection engineering. SPL, KQL, integrating detection engineering into organizations across the world. Awesome guy. Really, really knowledgeable. And then David French, this is kind of the inspiration for this talk. David did an absolutely amazing talk on detection as code from soup to nuts at BSides Dublin this year. If anybody was there and had seen that talk, you'll know how amazing that was. So if you're interested, you can just have a look at these guys after this talk. Highly, highly recommend it. So I'm going to be a bit selfish and I'm going to talk about how amazing I am to start this out. Thank you. Come see me after the show and we can talk about more. So I've been in the industry now for about 7 years. I've worked in a number of different industries, from finance, manufacturing, chemicals. I've worked a little bit in the intelligence arena as well, in consulting. But my primary experience is incident response, threat hunting, malware analysis, and more recently it's detection engineering. So my company at the minute that I'm at, Orbia, I serve as that lead incident response analyst there, and more recently have taken on the additional role of building out threat detection and overhauling our detective capabilities. So in my spare time, I like to find missing people all around the world, leveraging OSINT scripts, custom OSINT scripts, and websites out there. If anybody's heard of an initiative called Trace Labs, it's where you go out and basically gamify open source intelligence. Highly recommend you check them out because they do a lot of good, really, really good charity. And as you're about to see, I absolutely love memes, and take nothing seriously whatsoever. So memes, automation, it's kind of the name of the game there, so it is. So let's start out with kind of the problem that we have here, right? We have a problem in the SOC, and if you've worked in a SOC or you work in incident response, you work in threat hunting, you'll kind of know what a lot of the problems are when it comes to detection, right? So the first one is scalability, right? If you have a small team, maybe you have 3 or 4 people in your SOC, maybe you have a hybrid model where there's only 2 or 3 people internally, but also you're working with an MSP, or you're even just outsourced to an MSP altogether. You'll know that adding custom detections, adding anything new, any new content, is an absolute pain in the ass. It just is. It's really difficult to do that. So, kind of hard to scale. Inconsistent detections, right? If you're going to build a new detection control, the way I build one is completely different to how somebody else in this audience might build one, how my peers might build one. We have different skill sets, right? We have different backgrounds and different organizations. We follow different processes. So when we have an output of a detection control, it's just going to be completely different. There's no standard there at all. Costs and overhead. If you have lots and lots of detections, you need lots and lots of resources to be able to maintain those. And that costs money. Lots of it. Costs a lot in resources. There's just a ton of overhead with that, especially once you start getting into sort of 800, 900, 1,000, 2,000 detections in your environment. That starts to add up quite a lot. Fragmentation of tools. Detections don't just apply to SIMs. They apply to EDR, NDR, insert 3-letter nomenclature here, WAFs, 3-letter nomenclature. They all have different ways of implementing detection controls, right? They all have different field mappings. They all have different interactions with their APIs. Everything is all just different. There's no one consistency in the cybersecurity industry, as I'm sure you all know. It's a nightmare. So that's quite a big problem that we've got. Paper trails, and this is, in my opinion, the worst one. Right? I will share permission to connect my device to the TV. Very cool. Paper trails is the worst one. So, quick show of hands, if this has ever happened to anybody. Have you ever been working on call and been woken up at 3 o'clock in the morning because your friend in America changed the logic of a detection control, which then blew up the console? Has that ever happened to anybody?
I think it was you that thought it and seen it.
We're not going to shove blame on anybody, okay? It has happened, alright. It's a problem. It happened to me, so karma got me back, alright? This is a big one. Who can we go to see who made a change to our detective capability? What was the change? And how can we then remediate it from there? Paper trail is massive, especially when it comes to playing with EDRs and SIMs. Not a lot of them have that sort of version control capacity. And then outdated detection capabilities as well. And this isn't really one that comes up very often, but imagine you have a detection that it's really, really high fidelity. It always throws you out your true positive. It's absolutely incredible, right? But 18 months down the line, your organization changes, you have new log sources coming in, you have old log sources being taken out of your SIM, or your EDR vendor has taken away some detective capabilities of their logic. Your detection doesn't work anymore, and you don't know that. So that's just overhead and burden that you don't really need, especially if you have a really, really small team, right? This is where detection as code comes in. So hopefully you all have kind of a bit of an understanding of why we're all here today to talk about this. The problems there can all be solved by detection as code. Really bigging this up. So let's all get on to like the same wavelength with this. Detection as code is still kind of new-ish. It's been around since about 2019. People really started to talk about it a little more around that sort of time period, but not a lot of organizations adopt it, right? So because of that, there isn't really a clear definition on what this is. So for the sake of this presentation, I'm making up what my definition of this would be, but it's very similar to what a lot of people would define this as. And it's a structured and strategic approach to integrating it with the software development lifecycle. Taking your detections out of your SIM, plucking them into a version control repository where you can do a bunch of testing and automation and things like that. But we really need to kind of also talk about what it isn't, and I don't want to give any false pretenses. I have said that it will solve all of your problems, but it won't necessarily solve all of the problems, okay? Detection as code is not a silver bullet, okay? If you have 20,000 alerts that your SOC has to triage every day, you're still going to have 20,000 alerts that your SOC has to triage every day. As well, you're not really going to increase your true positive yield just from implementing detection as code. You're just going to be recycling the detections that you already have and putting them in code, detection as code format. So it's not a silver bullet. Morpheus says it's not a silver bullet. Here's an example of kind of what the detection as code workflow is going to look like. So kind of I've broken it down into 5 phases here, right? So the first is what everybody is normally familiar with is development of your detection content. So we'll start out by building our search query, doing the research. We're going to be looking at integrating it into SPL or KQL, EQL, whatever your EDR platform is using, XQL. I forget what CrowdStrike's is called, but yeah, whatever it is. We'll do the research there. We'll then define our metadata as well. And I'll show you a little bit later in this talk what that metadata might be, but detection name and description as an example. And then this is where we start looking at the detection as code side of the house. We start putting it in our code-based format. So for the sake of this presentation, we are going to be using YAML, yet another markup language. But you can use a whole bunch of other things as well. I've seen people store their detections as Python. In my opinion, a bit more complex to do that, but we're going to be using YAML, just kind of give it a highlight. From the next part here, we can then move into testing. And this is where we start to solve our problems a bit more here. So that outdated detection capabilities, we can now start to solve this. So We can lint our files, right, using stuff like YAML lint. We can perform integration testing to make sure that that test and that detection actually works in the platform that we want to put it into. I'll circle back to use case testing in just a little bit. From there, we can then move into the review phase. So we can do some peer review on all of the detections. We've just created one. It looks gorgeous. It's stored in YAML. It has all the metadata there. It looks amazing. And then we push it to the review phase, and our senior goes, actually, you have 50,000 changes. Go do the thing before we deploy this to our platform. So it's very, very good that way. Branch protection as well. This is absolutely critical. Any software engineers in the room? All right, then you'll know the importance of branch protection here. If somebody tries to push a broken detection directly to a main branch in GitHub, which is the most important branch, arguably, in the entire thing, and then that automatically gets pushed to your detection platform, and the content is broken, you're going to have a bad day. And in my case, you're going to have a bad night, because I don't want to be woken up at 3 o'clock in the morning dealing with that. So branch protection is pretty important there. And then artificial intelligence, I'm going to kind of leave you with this as a bit of a thought process, but it's not going away. We all know it. We hopefully love it. But it can help us in the review phase in a bunch of different ways, right? We can look at code styling. So is our YAML formatted and styled in a way that we expect so that when we pass it to our CI/CD pipeline, it actually works? Other things like code summarization. So if our detection content has a bunch of metadata in it and it looks incredibly convoluted, and then the query itself is 100 lines long, can we use some sort of LLM to then go, okay, sum up all the metadata, sum up all the query, and then give me an output. What is this thing doing? Which could definitely help in a review process. You still need a human at the end of that, but the time saved from that would be awesome. But then also maybe something like the duplicative code cleanup. Maybe I have a YAML file that has multiple of the same field in it. So maybe it has 2 detection names or 2 severities. Maybe the AI can then go, okay, well, I've identified this problem, go fix, instead of the AI just doing it itself. I don't know if we want to rely on it there just yet, but maybe, I don't know, maybe in 2027. Once we've done all that, we've looked at the detection. It absolutely is incredible. We love it. We're going to get it reviewed, and then we're going to have the senior approve that. We're going to the deployment phase. And this is where kind of the full automation starts to happen, right? Our CI/CD pipeline is built out here. It's then going to do a bunch of stuff that we want it to do. We then push it out to all of the REST APIs, the EDR platform, or our Splunk instance, or whatever it is that you want to push it to. We start pushing it out there. And then we can do more testing here as well. So we can start to do some use case testing and say, okay, well, here's my detection. Here's something like Caldera or the Atomic Red Team framework. Find the use case and then run it, make sure the detection works as we want it to, and then if it does, deploy it to production. We move into monitoring. Our detection is now in production. It's in the SIM. It's in the EDR. It's in the 3-letter nomenclature tool that you're all using and you all know about. Alerts are firing. We're having good days. We're having bad days. From start to finish, that's effectively what we're going to build and the problems that we're going to solve with detection as code. So from here, I'm going to kind of break down at a very basic level what sort of things we can incorporate at the phases here. So we need to kind of figure out, all right, Aaron, you've talked about all of this stuff and it's cool and you're going to solve all these problems with detection as code, but what is the technology you actually need to do, to do this? We need a version control system. That's kind of the most critical thing here. If we're going to be leveraging detection as code, we then need to solve a bunch of our problems, and most of our problems are solved with a version control system. That paper trail thing that we talked about at the start, there you go. We can solve this with GitHub, there's GitLab, Bitbucket, there's a lot of different ones out there. You can pick your poison, and it really just depends on organizational requirements. We need our CI/CD pipeline. This is kind of the critical part. It does all the automation, does some of our testing, or all of our testing, or any other requirements that you want to build in to your pipeline. And again, there's a fair few of these that you can use for CI/CD. There's Azure DevOps, there's GitHub Actions, there's Jenkins. Like there's a lot of pipelines out there that, again, organizational requirements. Pick your poison. Automated testing frameworks. This is going to help us massively when it comes to making sure that all those detections work. They're all structured effectively. So things like PyLint and YAML-lint to test your the structure of your file. And also, as I mentioned earlier, things like Atomic Red Team framework and Caldera. So kind of automated detection testing solutions. You can also integrate those at the pipeline level as well. And then I've put this part as optional, but really it shouldn't be. It can be, because you can kind of do everything that you need to do in a detection as code CI/CD pipeline in GitHub Actions or in Jenkins or whatever you want to do it in. You don't necessarily need a low-code or a SOAR platform, but it's kind of strange how detection as code's moving now, right? The security industry is moving towards low-code is amazing, SOAR is incredible, it solves all of our problems every single day. But detection as code is effectively, going in the opposite direction, where, in one side, you're moving to low code and SOAR to reduce code complexity, but detection as code is giving you more code to work with. And that's kind of where integrating it into low code and SOAR makes things a lot easier. It's really something that, in my opinion, we should be moving towards if we're going to be looking at detection as code. Can you just use GitHub Actions on its own and do everything? Yes. Can you use Tines and do everything on its own as a low-code platform? Yes. But for the sake of this, I'm going to show you kind of a bit of both, so then you can make your own determination as to what it is that you want to use in your pipeline. There are a couple of different low-code solutions you can use, or SOAR solutions, so we're going to talk about Tines today, but XOR, Phantom, Chronicle by Google. You can kind of pick whichever one you want there. They all have effectively the same capabilities for the most part when it comes to CI/CD. So let's start with what we need at the very beginning, right? This solves our inconsistency problem, right? We need a schema in YAML to effectively just have a consistent standardized detection across every single platform that we have. So think about what fields do we use in the SIM, that we use in the EDR, that we use in the WAF, that we use in the NDR. Like, what are the things that we can just standardize and normalize around? And then we'll just plug that into the YAML file and we'll just use those for every single detection that we have. Easy. You need to define this schema very, very well, so you do. So here's an example of what that might look like. So I will say it doesn't include everything that you can include. This is very much whatever it is that you want based on your org's requirements, right? So for your metadata, you'll have your detection name, your description. These are pretty straightforward what they are. The author of the detection, so who built this, who did the thing. The severity that detection is going to trigger at, if it does trigger. And then maybe you'll want to include some references as well, right? So if we're building a detection for the newest CVE that come out, let's say it's called, I don't know, Log5j, all right? Let's say Log5j comes out next year. I'll be taking PTO that day, don't worry. We want a reference to that. We maybe want a reference to a breakdown of the attack vector and the full chain, so that if we need a bit more information on how the detection works, we can just go and reference that URL somewhere. Also, referencing your minor attack techniques and tactics in this day and age should almost be mandatory if you're going to be going down the CI/CD pipeline route, because then you can use that downstream for a coverage assessment of your entire environment, which would be awesome. So you can kind of store those in your references there. The version of the detection. So I built the detection for Log5j. It's incredible, but all of a sudden I've missed something out doing my research and this detection isn't viable anymore. My friend comes along, edits it. We need to make sure that the version is updated there. We're using a version control system, but that doesn't mean you can't have version 1.1, version 1.2. And then tags as well. This is another thing that we can use downstream. So if we want to tag this detection as it's used for endpoints, it's used for network, it's used for mobile applications, anything like that. And then once we do that, we can move into the detection phase. So what's our query? This is kind of important because we're building detection as code. You kind of need the query there, otherwise it ain't going to work. The event name, and I will just point out as well, detection name and event name, two different things. Not a lot of people think that, but they're two different things. So event name is what an analyst at the other end of the detection is going to see when it triggers. So network log5j. The detection name might have some additional metadata like a UUID, unique identifier of some sort for that detection. So it might be 114125 underscore network underscore log5j exploitation attempt. So something completely different there. We need some next steps. Okay, alerts triggered. What are we going to do with it? And then some drill down information as well. So if there's an analyst in there and they say, all right, well, I need to go and triage this. I know what the next steps are. Click this button and the query that I need to triage with just pops up. So very important when you're creating detection content to give the analyst as much context as possible. And then timestamps as well. We need to create time for the YAML file. We need a time that it was last updated, preferably if it's just standard UTC. We need a query start and end time because we're not creating detections that are going to search our entire historical database. That will be long. Sometimes you will, but for the most part it'll be search last 15 minutes. Scheduler type, is it a real-time detection? Is it a continuous detection? Is it scheduled? What kind of detection do we have? The review cycle, so if this is a critical severity alert that we need to be on top of all of the time, like log5j will be, how often do we need to check to make sure that this detection is not outdated? 90 days, 120 days, a year, probably not a year. You don't want to do a year. And in the cron schedule, it's pretty straightforward. How often is this detection going to look for bad? Every 15 minutes, every 30 minutes. We all love cron. So indeed. So we've built our detection. We have our YAML file in place. Let's push it and do some fun things with it. So this is where GitHub Actions starts to come in. Is anybody here familiar with GitHub Actions? Or has used it in the past? All the software engineers? Anybody who's not a software engineer? 1, 2? Okay. 2.5. Okay, awesome. So GitHub Actions is amazing. So it is. It really, really is. In software engineering, you'll know exactly why this is amazing. You can effectively just build automation workflows. That's what it's for. But the cool thing about it is that it integrates so well with your Git repos. So it does. You can have it trigger based off various actions, right? So I've just created my detection file. It's absolutely amazing. It's been pushed. What I can then do in GitHub Actions is have a check to say, okay, if any new YAML file is pushed in this part of the repository, that's a new detection. So run all these things. Do all the things with it. Push it to my synth. Push it to EDR. You can get as granular as you want here, right? And the nice thing about GitHub Actions is we built our detection in YAML. GitHub Actions works in YAML as well. So it's not too much of a jump to go from learning YAML to build your detections to building your GitHub Actions with YAML as well. Very, very cool. Here's an example of what your GitHub action might look like. And I want to stress this is a very basic level just for the sake of this talk. You can get as advanced or as deep as you want when it comes to building the detections. So what we're going to do is our YAML file's been pushed. The GitHub action is going to spin up what's called a runner. And that runner is going to do a bunch of things. So it's going to check out our detection repository to grab all the data out of it. We're then going to use a script to pull back all of the detections that have been updated. So it's going to search for all those YAML files that have been changed or added or anything like that. We're then going to just do some basic linting and testing just to make sure that it's structured and actually works. We're going to lint the files, and if they are successfully linted and tested, we're going to push them out to our Tines webhook to do a bunch of other cool things with. And then once that's done, clean everything up, shut down, and that's it. So this might be a bit tricky to read, but I'm going to walk you through it just real quick. This is the back-end YAML file of a GitHub action whenever you're creating your CI/CD pipeline. So as I mentioned, it's going to enable once you push a YAML file. Let's see, does this work? It does not. Okay, well, I tried. It's going to push, start this GitHub action up when you have a YAML file that's been pushed. It's going to run an Ubuntu-based runner. And then from there, it's going to do a bunch of the different steps. So we're going to use a checkout GitHub action to check out the repository. We're going to use GitHub scripts to find all the updated detections. And this can be JavaScript, it can be TypeScript, it can be Python, it can be Bash, it can be effectively whatever you want. So we're going to grab all of our updated detections. Once we've done that, we'll run through and do some things to run the YAML linter and test them to make sure that the structure is working and it is exactly as we want it to be, as defined in our criteria. And then we're going to send each of those to our Tines webhook. So we'll receive a base64 encoded array from the lint detection files action previously, and then decode that, and then for each thing in that array, send it to Tines. So again, it's very, very basic what you can do with this, or what I'm doing with this right now, just as an example, but you can have a bunch of different tests all thrown in here. You can have a bunch of different checks to say, hey, is my detection working as intended? Yep, absolutely. Fire it off. You can send it to multiple different places and just do a lot of things with parallel work streams. But I'm going to show you a little bit more about that in Tines. What's Tines? Has anybody here used Tines before? I love this guy. This is great. Software engineer, you know everything that I'm going to be doing here today. It's great. So, full disclosure, I'm not paid to say this. I love Tines. I will shill Tines to the end of the day. The platform is amazing. The people behind the platform is amazing, and they constantly roll out features all the time. It's a low-code platform. You can effectively call it a SOAR solution as well, but it's a low-code solution, and we build automation. That's its job. That's what we do with Tines. And what? Right? How can it possibly boost my detection capabilities? Well, we've already talked about a lot of the testing that can be done with it, but one thing that Tines is really, really good at is parallelization of all of your stuff, because it's a low-code SOAR platform. So we can do a bunch of other cool things, right? We can do some health checks to make sure that our detections are actually alive and working. We can have some deployment metrics to say, all right, here's my CI/CD pipeline. I have just clicked deploy on this detection. How long does it take to deploy 100 detections to all of the platforms that I've just made updates for? Oh, 3 minutes. Great. Love that. Love a good bit of time saved. And as everybody here knows, leadership love a good metric. So they do. So this is absolutely fantastic to have. It's already built in Tines, but there are other platforms out there like Torque and Swimlane and your XORs and things like that as well. But then you can take that detection also and say, all right, well, I want to do this remediation action whenever that comes through. Plug it into the remediation action. I want to reset a user password. I want to kill sessions. I want to isolate a host. I want to cut off an entire arm of my business because Log5j has totally compromised it with whatever else the payload is there. Don't do that. I'm not recommending that, by the way. So, what I'm going to show you here, this is kind of Tines in action with detection as code. So, looks kind of complex, really, really straightforward. So, we start off by bringing in our YAML file through the webhook here at the top, and then we're going to do 3 different things with this. Again, very basic, but we're going to do 3 different things. The critical path is in the middle here. We're going to create our detection in our chosen SIN, or our EDR. I'm just using Splunk as an example here. Again, I love Splunk. We're going to check that that detection was successfully pushed, and if it was, great. Send me a message in Slack and let me know that everything is fine and dandy and rosy, and I absolutely love it. If not, send me a really angry message in Slack so I know about it. And then on the right, we have another work stream where we can say, okay, here's my YAML file. Extract the query from that. Also extract the MITRE data, if any exist. Map that to a use case in the Atomic Red Team framework. And then run it on my VM, run it in my container, and make sure that that detection actually fires and works the way I want it to work. We make our HTTP request to do that. This can fire to whatever you want. Again, organizational requirements. And then we do another check. Did this work? Okay. Sent me a lovely message on Slack. And if it didn't work, shout at me on Slack. And then the third work stream over there on the left is, okay, I have my YAML file that is coming in from my webhook. Take that and leverage AI to switch everything about it based on the prompt engineering within the AI action. Take everything from my YAML file input, convert it all to Markdown in the exact format that I want, and then push it out to my detection library, where I can just go and type in one word like log5j, ntds, C/Windows, or have a specific IOC, whatever it is, so that I can then just have a repository of all of my detections across all of my source systems and be like, all right, we're covered for this if somebody comes asking. And you can build that in, MK docs and read the docs. It's a really, really powerful one to have because you can just push the Markdown file and it'll just work. It's awesome. And then we'll do one more trigger here. Anybody know what that trigger is? Yep. Make it work. Does it work? Send me a lovely smiley message on Slack. If it does. If it doesn't, shout at me on Slack with that really obnoxious exclamation mark emoji that everybody hates. So Tines is really, really powerful here. You can have 7 work streams here instead of 3. You can have 50 work streams instead of 3. Really, the limit is your imagination here as well. But going back to what I'd said earlier on, it feels like detection as code really should be moving towards leveraging these platforms as opposed to being in GitHub Actions. Now, you can do a lot more with GitHub Actions just because of the nature of the feature set there, but it won't be long until you can accomplish 90% of that in a low-code platform. So it's very awesome to see. And did I mention at all that everything that we've talked about today, it's all free? Every single thing. So YAML, you can just go and learn. Create your own YAML files. GitHub is obviously free. GitHub Actions are obviously free. Python, Tines, all these things are free. You can go sign up to Tines right now and have just a story there, build out your own detection as code pipeline that you can walk out of this room now and then by tonight have this exact thing just working at home. Really, really cool. I have a couple of additional resources around detection engineering, detection as code here. So if you want to look up what GitHub Actions are, Tines and YAML, go check them out. I have a really, really good article from David French that I mentioned earlier on. This is a really, really good one. If you want to go home and build this yourself, start to finish, excellent article. Cannot recommend it enough. If you're interested in detection engineering as a whole, Detect.fyi has amazing articles about anything to do with detection. And then if you're starting to get real serious about integrating your own threat detection team in your organization, start looking at things like your maturity matrix. So Kyle Bailey made an excellent maturity matrix on detection engineering that you can kind of take and either run with or enhance to then start to build out things like your strategy and where you're going to go from your threat detection for your threat detection team. And that brings us to the end, folks. I hope you've learned a lot here. If you haven't, feel free to come to the after party later and shout at me and tell me that you haven't really learned very much from this. I'll still appreciate it. But I'll open it to you all now. Does anybody have any questions? Hello, sir.
So from your point of view, is you show action flows and you show an operational sheet. It's more for the softless operations.
I think it's a good question. So the question was, does this show a shift to a SOC-less architecture within your organization? I would say yes and no, right? So I think the thing with that is you're still going to have your detections at the end of the day, and yes, you can have as many automated remediation workflows in those as possible, and technically you could, but we're all kind of aware that while we tune these detections to be highly granular and super focused on a very specific indicator or behavior or instead of indicators of compromise, they are prone to false positives. I don't think we're really at the level in the industry yet where we can say we can go truly SOC-less with this. For some of those quick win detections like brute force or anything like that, absolutely. We dealt with that years ago, but when you're getting into very bespoke behavior-based detections, I wouldn't personally think we're quite there yet. But Maybe in a couple of years. I don't know. We'll see how technology goes there. Any other questions? Hello.
I'm in QA, so I always ask questions. What's the metric of it works? I just hear false positives, false negatives. Because you say, when it works, send me a smiley. When it doesn't work, show it me. So when should the quality person, SOC analyst, start shouting to you?
That's an excellent question. The informal answer to that is all the time, because I always do everything wrong. But it starts when you're starting to build it out. When you're fleshing out your detection as code architecture, you're going to be starting to think about these things, right? When in the QA process is this going to break down? And the reality of it is, when you're building out your detection as code, you build it the first time and you QA it once, and usually the pipeline itself just works. So it does. You don't really ever need to go back and change it unless you're adding another feature, in which case of course you're going to QA it again. But if you can get to a stage where you're implementing a bunch of your automated testing for your integration testing, your use case testing, all the different kinds of testing you can do, we'll keep that QA phase to the minimum. Now, can you implement detection as code as a entry-level SOC analyst? Yes. Can you implement detection as code as an entry-level SOC analyst and go through all the QA processes and no testing and back-end engineering? That's where it gets a little trickier to do, which is why I try to keep it very basic today. It's very much a look at the proof of life of how this can work. Now go out and flesh out all of your additional features and quality assurance tests and everything else that you want from there. Time?
Yeah, time.
All right. Thanks for coming out, everybody. I really appreciate you coming.